Hi students, question number 11. A hollow sphere is filled with water. It is hung by a long thread. You can look at the picture. As the water flows out of a hole at the bottom, as the water flows out of a hole at the bottom, the period of oscillation we have to explain what will happen to the period of oscillation. Will it remain constant or continuously increases or decreases or alternately increasing and decreasing? Now first of all, what is the expression for the period of the simple pendulum if its length is L and acceleration due to gravity is G? So T is equal to 2 pi into square root of L by G. So this implies that T is directly proportional to what? Square root of its length. So this is also called as the law of length of a simple pendulum. Okay, now in the first picture you can see that the hollow sphere is fully filled with the water. So what do you mean by length of the pendulum? Length of the pendulum is the distance between the point of suspension here. So this is P is a point of suspension up to the point of oscillation. So the point of oscillation is nothing but the center of gravity of the bob. So this hollow sphere filled with the water is called the bob here. So it is having some weight, and where does the weight of this bob act at the center of gravity? Is it not? Okay, suppose if there is a hole at the bottom like this, if there is a hole, so as it is oscillating each and every instant, a few drops of water will be spilled out. So I have shown roughly the second picture. You can see that half the water has flown out. Through the small hole the water has flown out. Now what will be the weight of the bob now? Previous weight was full weight, full water was there. Now only partially filled with water. So now for that partial water inside the bob or the hollow sphere, the weight of the water will be acting at the center of gravity of the remaining portion of the water only. Is it not? So the remaining portion of the water is having some weight and its center of gravity will be somewhere taken as G. So now this is taken as L1 for example. For example, I will write L1. Okay. Has L1 increased more than L or not? So previously up to this only we measured L. Now L dash or L1 is greater. Okay. L1 in this picture, L1 is greater than L. So I will write that T1 is proportional to square root of L1, or this implies what? T1 is greater than T. That means what? Initially the period of oscillation increases, is it not? So it will be stage by stage continuously increasing. Okay, what next is going to happen? If all of the water will leak outside the sphere will become empty. Empty sphere is also made up of some material only. So the empty sphere's center of gravity, where does it lie? We have studied, even if it's a hollow body, means it is acting at the point which is a geometrical center. So once again the G is shifted back to its original position because the sphere is totally empty now. Is it not? So initially G was shifting below its position, below its center. Then after fully the water has gone out of the sphere, G will be coming back to its original place. So once again what will happen? This length, this length will come back, so that this L is now less than L1. So once again what is going to happen now? Finally T is once again proportional to L. So initially T will increase because the length of the simple pendulum was increasing. When how long? Till the water gets empty. So when the water gets empty, what will happen? Once again comparing to L1, L is less than L1. Therefore what will happen? The period of oscillation once again decreases. So initially during the oscillation of a leaking pendulum, what will happen to the period? It will increase. Then when all of the water will be removed from the hollow sphere, once again the period will decrease. So first it increase and then it will decrease is the option. Therefore here option A is the correct answer. I hope you must have understood well. Fine.